the chicken owners have 2 big bulldogs and a German Shepherd, so that must protect the chickens.
Okay.
So anyway, all right. So yeah, I think what I'm going to do is, if you look at the examples, I do have a number of other examples, and I actually planned to go through them first. We're taking enough time the way it is. So basically, there's some image processing routines that I'll go through next week when I do the video, because like the other stuff I plan to talk about, there's no there's no reason that you actually have to do those in class. So they're more of a demonstration type thing. And this structured array kind of fit in that same category. So for the final exam, although you'll be doing regression, you're not going to do structured array stuff. Okay. All right. So let's talk about the final exam and kind of look at approaches to it. Okay. So we kind of already have gone through what you're going to do. You're basically establishing a relationship in a particular area between elevation and temperature, and that's called the lapse rate. The slope is called the lapse rate. Technically, it's the slope times 1,000. Slope times 1,000 is the lapse rate. Okay. So, so what your script needs to do is that it needs to be able to accept a feature class or a feature set as an input, and that's the only input, and then you're going to feed it a path to where you want to store the output data. And we haven't actually talked about what that output data is yet, okay? But we're going to do that now. The output data is actually going to be the model temperature values. All right? So I'm going to do what I've done in the past and kind of come up with a bare bones stuff. A bare bones script that you can start with. So we've got our histo example right here. And that histo example actually does the beginning part of it. Okay? So I'm going to start with that, and we'll call this final exam. We'll call it final exam starting point. So I'm gonna save this as final exam starting point. What I'm going to do is get rid of all this, those comments, and we don't actually need this line. We're still going to need spatial analyst. We're still going to need to extract by mask. Okay. I'll delete all this out to about here. Yeah. I think. Yeah. No, I'll leave that in there too. All right, so that's what I'm going to start out with. Now, I'll start at that point. Okay. So I just took that other example. I started out. So what does this do? Well, this stuff that's left basically takes a raster. It takes a raster and extracts just the area of a polygon into a new raster. That's what it does. Okay. So that's starting out. We need to do that as part of the thing, because what you need to do is you need to get 2 rasters or 2 arrays and feed them both in. So this has got your X array. Is it actually the X array? The X would be this axis, elevation, yeah. The Y is temperature. The Y-axis is temperature. So you need to get your Y. I'm going to organize this a little bit different. Maybe put some different comments in it. Call it something slightly different. So, yeah. So this code right here gets the X data and creates an array of elevation values. So how many times do we need to do this? If we're trying to take the X values and compare them to the Y values, we have to do this again. What are the Y values? So our scatter plot, we're going to have two things in our scatter plot. Let's go look at the scatter plot example that's still up here. So the scatter plot takes a bunch of X values and a bunch of Y values. So right now we've got a bunch of X values. We've pulled them out of that extract by mass. We pulled them out of that array. Where do we pull our Y values from if we're going to compare Y being, X being elevation and Y being temperature? Where do we get the Y values from? From the temperature data set, okay? So you need to do all these same things again. I'm gonna actually delete that, but just put the comment there, an array of all the temperature values. See what I'm saying? So you need to you got your X data, you need to get your Y data and create an array of all of the Y values. This actually needs to be X array too. I'm going to save this up there. So you're getting your X values, you need to get your Y values. Yes, exactly. That's the only temperature values you have. It's the June temperature value. Okay? All right. Then, next step is that you need to find the slope and the intercept and find the correlation. Go with, I'm not going to spell right. You need to find the correlation coefficient. And you could do that using these two commands. Okay. You actually don't even need this line right here technically, because that's going to be putting it onto the plot. Okay. You find the slope, you find the intercept, you find the correlation coefficient, or you do it like I did it in that other one, this scatter example, and you use the, no, not the scatter example, structured array example, and you use Lin regress. Either way is fine, it'll give you the same exact answer. So you're gonna find your slope, you're gonna find your intercept, and you find the correlation coefficient, right? Once you have the slope and the intercept, you can report that. That's one of the requirements. Go back here. Okay. The other requirement is that you send back. You create a new raster that contains the predicted temperature values. How do I get the predicted temperature values from the slope and the intercept? We're going to talk about this because this may not be something that you just know, okay? But the slope of the intercept is a line, basically. It's a definition of a line. So to get the slope and the intercept values, anybody know how we get the slope and the intercept values. Those are the M and the B. How do we actually create create an array to save back out. That's what we need to do. But let's go over the formula for that. It's pretty easy. I already wrote it right here. So that's that line. So what this means is that you'll take the X array, which is this one, you multiply the X array times the slope, which is the scalar value that you pull out here, and you add the intercept value, which is this intercept value, and then you'll set that equal to a new array. So it's going to create a new array using this formula. It's a simple formula. Right? And then finally, you will use numpy array to raster to create a raster and then save that raster out to file. So yeah, you're going to take this array, you're going to use that array to create a brand new raster, and then save that out to the user. There's a little bit of cleanup work to do in here, okay? Because now this one will be the right dimensions. So this will be the right dimensions because this array, it's going to be the same dimensions as that array, which is right here, okay? So that array will be the same dimensions. However, when you write that back out to file, you're going to have to know the cell size and the corner. Where can you get the cell size and the corner? Yeah, you're going to find out that from actually this is X, but you should actually be using this X array. I just want to make sure you know that you should not be using this X, because this is just a one-dimensional array. This is actually the two-dimensional array. So in here, get the extent and cell size like you did in Lab 11. Okay? You're going to use that down here. Save the raster out. To the file specified by the use numpy array to create a raster and use the extent and cell size of XR. Yeah, so let's go back to Lab 11 to show you what I'm talking about. No, you're not going to give that to the user. If that's what you mean by a parameter, you're going to pull it out. Is it Lab 11? Yeah. Yes. So you're going to pull it out of. See, I'm getting the extent and the cell size of this raster right here. This is where you did it last time. So you can copy it over and do the same thing. Okay. So it's of the raster actually. Get the extent and cell size. This will be of this one. So you want to get the extent and cell size of the extent and cell size of this raster, because that'll be the one that's the proper extended cell size, like you did in Lab 11. Right? So this is being recorded. This right here, line 12 and 13, is the area where you get the cell size. Okay, that's how you get it. Didn't actually use it yet, did I? Yeah, I didn't. I mean, the final solution isn't in there. Okay, but go look up raster to NumPy array, and you'll see that you can feed it the extent and the cell size as part of the. Go look up NumPy to. NumPy array to raster. And you'll see in the help there that you can feed it the cell size and the lower left corner. So look at this example, and you'll be able to do it. Okay. All right. Now that right there will, assuming that works, you can turn that in, and although it's not built into a toolbox, you'll get points for that. Let me go back over here for a second. I'll save this out. You'll be able to look at this code. Okay. I'll just save that for now and look over here at week 12. Okay, so let's look at what gets you points. If you turn it all in and it works, you're going to get 85 out of 100. Okay, you have the opportunity to earn extra points for completing the following. So, if it works inside the toolbox, this code that we've done already doesn't actually run it inside of a toolbox. You'd have to add that on. Okay. So. All right, so you'll get 4 additional points for allowing the user to define a custom area. So instead of a feature set, allowing them to draw a box. Now we haven't done that in a long time, but if you go back and look, and you can accomplish that task, you'll get extra points for that. So if you allow them to draw their own box, then you'll get 4 extra points. That's a feature set rather than a feature class. So one of the things is when you create the new toolbox and you add the parameters, the first parameter, if it's a feature class and they can pick on disk which one they want, you won't get the 4 points. But if you choose feature set and you allow them to draw a polygon in the box, then you'll get those 4 points. Okay, so that's extra. That'll get you almost to an A just doing that. 2 points for writing the correlation coefficient and the actual lap rate, which is the slope times 100, to the processing window as a message. So what that means is that you use add messages, also something we haven't done in a few weeks. Okay? Add messages. So go back and read the help. So a lot of these extra points you're getting for being able to dig back and find the answers to questions. So go back and find a way to write these into the window. Just add messages is the way to do it, or add message. All right. Okay, 4 points for styling your code to include a function that takes a path to the feature class and an output raster, and a path to the output raster. So instead of having your code all execute in the same one, if you build it into a function, you'll get 4 extra points. So if you, somewhere up here, you type in def whatever you want to call it. I'm just going to call it regress or something. And you say input FC and output raster, and then you build your function here. I'm just going to comment out this. So that's what I mean by that. Okay. You get 1 point if your solution is turned in before May 2nd, and another 1 point if it's turned in on May 1st. So basically, you get a few little points for turning in early. Okay. All right. Now this is why I didn't tell you which one of the two that are left is the right answer, because you get 3 points for collectively inferring which of the 3 sample areas I included has the highest humidity. So it's not the one in the desert southwest, we already established that. So of the remaining 2, you may have an idea of which one it is, but the one with the highest humidity is the one with the lowest lapse rate. Okay? Okay, so your 1 sentence definition could be just what I just said. Okay. So you basically tell me why it's the right answer. Okay? Right. You can't get those extra 2 points. You won't get those extra 2 points at all if it isn't correct. If it has a few minor errors, like if it still works and maybe some of the no data values weren't correctly changed back, or something like you have some 999s on the edge of your data set, something like that, you'll still get the 2 extra points. But if it doesn't work, you also don't get any of the 2 points for turning it early. It has to actually work and produce almost what it should produce in order for it to be counted as early. All right. So there's also some negative points where you're going to lose points for doing the following. Okay. So basically, if you turn it in after May 3rd, you're going to lose points. But the most you can lose for turning it in by May 10th, which is the last day, is 7 points. All right. Okay. So number 2 here is you get 5 points off your script if it's not built into a tool, or if it only executes from IDLE. Okay. So even if you have it built into a tool, but your tool doesn't actually do anything besides just run the script, it doesn't ask for any parameters, that doesn't count as running on a tool. It has to actually allow you to select the feature class and allow you to select the output. Let's talk for a second about what the output type will be. Okay? The output type is going to be a raster data set. Okay? So the user is going to be able to select a raster data set. And just as another little clue, you're going to have to say that is output. If you forget and leave it as input, it won't let you actually specify it before you run the script. Okay? All right. So now there's another 30 points that I'm going to mess with. In other words, if you just get to the end and you just have to turn something in, turn it in. Okay? So there's some discretion here, but there's a solution that executes, but it has minor logical errors. You're still going to get the right answer. These are like, maybe there's some no data values where there shouldn't be no data values on the edges, or your function for the slope your function that reports the lapse rate doesn't multiply it by 1,000. That falls into this category. Okay? Although you can still get the right answer because you'll be able to see which one's biggest. You're not actually getting the right lapse rate. You're not multiplying it by 1,000. Anyway, other minor logic errors where you can still get the right answer, technically doing something wrong, you're going to miss 5 points. You may actually miss less, like so 1 to 5 points for that type. Okay? And these aren't cumulative. So you're going to miss 15 points for a solution that works, but it's missing just one major component of logic. It leaves off a step in the processing. Like if you can't figure out one of the steps in the processing portion of it. For example, probably the one that I'm thinking most people, well, not most people, but the most people that don't finish it will have trouble implementing this. Okay, so if you can't figure that part out, then you'll lose 15 points. You won't be saving the raster out, but you'll still be able to get the right answer because you'll still find the slope and the intercept. Okay, but you won't be getting the output raster. So basically, if your solution doesn't output anything, then you're going to miss 15 points. Okay, and because you can't turn it in early, you're basically, if your script doesn't output anything, the highest grade that you're going to get is a 70. Okay, so well, not the very highest grade. I suppose you could earn some of the. You could earn these 3 points back. Okay, but if your script doesn't, yeah, you're going to be able to do that. Yeah, no, that's not the highest grade you could get, but it's still going to be in the 70s if you don't, because you can't turn it in early. So it's probably going to be in the high 70s. Okay. You'll get 30 points off for a totally incorrect solution, basically, or up to 30 points off. Maybe I'll give some partial credits, but you get 30 points off for one that entirely leaves off most of the logic. So, if you turn in something, and I can see that you've attempted to make a script that does this, but it basically doesn't work correctly at all. And there's really only 3 steps here that you're going to have to add, but there's more than 2 of those steps that aren't working right. Then you'll get 30 points off. So now your highest grade would be in the D range instead of the C range. All right, but I think that most people, especially if you work through it, you'll be able to. I don't think a lot of people will fall into that category. Not a lot of people did for the midterm. Most of the people fell into one of these 2 categories. Either they got 5 points off or 15 points off. Okay. And actually, some people missed 5 points for not turning it into a script. I mean, turning it into a tool. I wrote this up that you turn in 1 tool to me, but later I was thinking, 1 toolbox with 2 tools in it. I don't care if you turn it in as 2 toolboxes, but it would be a little bit better if you turn it in as 1. So anyway, you've got another script to write. The other script should be a little bit more straightforward. After I read it, I'll decide if I want to do the same thing we just did. Okay. You're going to create a Python script tool. It's going to take a single feature class and let the user choose a field. Then, using the histogram code that was demonstrated in class, create a histogram of the values in that field. So this is actually much easier than the first one. However, you either have to use a search cursor, or I was just thinking about this during the break, that you could alternatively, instead of using a search cursor, you could use the structured array code, which I told you wouldn't have to know for the test, and you don't. But the structured array code will actually run a lot faster. So if you want to use that, you can. I think it's useful. So in any case, you have to get 1 column's worth of data either in a list or into a structured array, or into an array. One column's worth of data into an array. So the user is going to be able to select a feature class and then select a field in that feature class. All right. So then you just need to feed it into the histogram formula. I don't care what color the histogram is. I don't care about any of that. You just feed it into the histogram formula, and it runs. You choose an appropriate number of bins. It can be 50, or you can change it to a different number. So I wrote on the test, you'll need to use the search cursor to loop through all the values, and that's what I was picturing. Okay? So most of you will probably end up doing it that way. So this is the pseudocode. Create your search cursor, and then inside your search cursor, you're going to use the search cursor just to get the values in that field, and then loop through all the values and append them to a list. And then that list is what you're going to feed into the histogram code. Okay. All right. There's one thing that I'm thinking of that I wanted to demonstrate that I didn't get to because I changed it. So I'll demonstrate that in a second. All right. So rather than the correlation coefficient, and by the way, rating is going to be the same, except rather than the correlation coefficient and the lapse rate, you're going to display the mean and the standard deviation values in the list. Well, you wrote code to create the mean, to calculate the mean and standard deviation of items in the list. So you can go back and look at that code, or alternatively, there are actually pre-coded ways to do that, especially in NumPy. So you can convert it to array, and then numpy.max, we showed you that. Well, there's a numpy.mean, and there's a numpy.sum. So if you go look up those functions, you can get those values. I don't care how you get those values, but you do need to display the mean and the standard deviation to get those 2 points. Okay? So display those in the processing window. Second, including your code a histogram function that takes a list and creates a histogram. That's still 4 points. And then that's the same. Basically, if you include a function in your code, you get those 4 points. Rather than correctly inferring an answer, you can earn 3 extra points by including error checking logic that makes sure that the field that you specified by the user is numeric, and exits the script gracefully and reports that to the user. So it basically stops running and puts in the output window the field you chose is not numeric. It uses add messages to put that in the output window. So that is the final thing there. Now this one, okay, it just takes a single feature class and a field. All right. Now one thing I wanted to show you, and I don't care which way you do this. So when you create your histogram, you could actually throw it up on the screen, like we had it in there. But I also wanted to show you that there is a way to do this differently. And all it is this. So instead of plot.show, if you say plot.savefig, you just specify an output location, and it will save that at that location. So savefig is the function. Instead of throwing it up on the screen, it actually saves it to disk. So now when this runs, I'm still going to get those errors I was getting before, I'm sure. Yeah, but hopefully it still got to that line. So ctemp, what do they call it, test? Actually, I don't know if it's going to get to there because of the error. So let's, and it's because my Python install isn't doing really well. So something wrong with it. So let's go to the histo example. That's fine. And just save that one because this one runs just fine. So plot.savefig. And it's going to save it out to that location called test.png when it finishes up. Instead of showing it, and I'll put this example will be up there, instead of showing it. So see how it ran? Now I've got test, and this is often more useful. So this is easier, like if you're going to actually prepare it for publication. So if it's going in some prepared report, or if it's going on the web, it's better if it's actually a file. So savefig is the function that saves that out. Okay, so it's a little bit off track, but that's, and I didn't specify whether you should save it here or just show it. So it doesn't matter to me which way you do it, but I thought I'd show you that. Because sometimes if you're writing code, after you know the histogram part's working, it's kind of annoying to have to close that every time you run through it. So, oftentimes when I'm doing this for like when I was preparing that research article, I get it working, and then I save it out. I get it working using the display button. And I actually save it to a file. And, all right, are there any questions about the assignments, either one? I'm trying to think if there's any. All right, if there's any other things. So, there is something else I wanted to mention. Although I did mention it before, but I wanted to explicitly mention it. In our catalog, if you look at this data, so I wanted to make sure you know the purpose of every data set that's in there. When this opens up, the ones that are called sample 1, sample 2, sample 3 are for your testing. For the histo example, you're welcome to use this this data set called, for the sample points data set, you can use for the histo example, you can use this data set, and then the user could select one of these fields, or you could use your own field. The last time I taught this course, I made them use the city's statistics, so they could choose any of the statistics about the compactness of the cities to make a histogram of that data. Okay, so all right, okay. This extract USA 1 and 2, those are just data sets that I actually made. They aren't in your data. I made them during class today, so that's why it won't let me delete them. All right, the correct output, sample 1, sample 2, and sample 3, these are what your data set should look like. This is the model temperature value based on the slope and the intercept that you should get with your data. So one thing that you could do is actually, once you run it and you get an answer, you can take this data set and subtract off your data set, do the subtraction problem, and see if there's any differences. All right? Now, the value, or you can just bring them both up into ArcMap. You've done that before. You bring your answer up in ArcMap, and let's just say this is your answer, although it's not going to be. Okay. So I go to zoom to layer. Oops. Zoom to layer. Okay. just for fun right now, let's say that USA temp June average is your layer, and the correct output sample is my layer. If you want to compare them, you can just hit this little I button and drop down and choose all layers. And then when you click on it, it'll tell you the values. And these values aren't going to be the same because one represents the model temperature, in other words, the trend line, and one represents the actual temperature at that location. But yours should be the same or very, very similar, maybe out to 2 or 3 significant digits. So your 2 data sets. So you'll have correct output sample 3 and you'll have my output sample 3. You just click on them and see if they're the same. And if they're the same, then you did it right. If not, then you need to re-examine it. If they're really, really close, then they're probably the same, just rounded somewhere else. Yeah, so this formula is only the general formula down here that I just want to make. I know I keep bringing things up, but this formula is just a general formula. Okay, so the intercept might be an integer. If it's an integer, you might have to convert it or something like that to a floating point number in order to get the output floating point. I don't know that off the top of my head. I have already written up the answer, but I don't have it with me. All right, I'm just trying to think of a few things that it could be. All right, there's nothing else here that you need. This mask file was just something that the data that I was preparing. This also is both of these data sets were data sets that I needed to create the sample points. So there's a routine called create random points, and you can feed it a shapefile to constrain those random points in there. So that's why I needed those. All right. Any questions? All right. Okay, I'm just going to give you one more. Okay. So in order to get a totally correct answer, you are going to have to you don't have to do it in code, but when you run it or in code, you're going to have to set the snap raster, the cell size, and the when you do this, because if you don't, let me bring this back up here. Snap raster, the cell size, and not the extent actually, the snap raster and the cell size. So see how those match up in the corner? If you don't, those won't match up. See how they match up exactly, those 2 data sets? If you don't, then because I arbitrarily drew that polygon, the polygon actually goes up to like this high, and so we'll put the corner of this cell up here. You're still going to get the right answer, like you're still going to know the right one, but it's not going to line up exactly with the other data set.
Are we going to do that twice? So will we have to do that for the final like output raster? Or will we just do that?
No, you won't. So you don't actually have to even do it in the code. You could actually do it because the tool will force it to happen. See what I'm saying? So, but the answer to your question is it only has to happen once. As long as when you do this extract by max, the snap raster and the cell size is set. I guess you don't even really need to set the cell size because the cell size will always be the cell size of the thing unless there's some other. That's the default. The default is correct in this case, but the snap raster is not correct. So, yes. As long as it's set, the snap raster is set here, before this executes, this raster will match the original raster. You actually don't have to put it in code, but your result won't look like my result unless you set it either in code or when you execute in the toolbox. It'll be slightly off. Just set it right here somewhere. Just arcfly.env.snapraster equals the elevation, or it can actually be the elevation or the temperature data set. Because you're gonna execute it twice, but it doesn't matter because they're already lined up perfectly. All right. You don't really. This isn't even the right code, but in this part right here. So before you execute extract by mask, either in code or there, you need to set the snap raster.
Just snap raster, but I'm not extended.
Well, the cell size, the reason that you don't need to do that is because the default cell size is the cell size of the data set you're working on. So, like, let's say you're multiplying two data sets together. Then, in that case, you need to set cell size because the cell size is always going to be the maximum of the two data sets by default. But since we're only dealing with one data set, you don't really need to specify cell size. You only need to specify snap raster. And if you do set extend, the problem with that is that the whole reason you're doing this is that you're changing the extend. So don't specify extend. Only specify the snap raster. So I would put it in my code at least until you get the code running, just so that you don't get confused when you're like, why doesn't my data set match your data set when I zoom in? Well, they're almost going to be the same, but they're going to be off by just a little bit. And then the only other kind of thing, like I already kind of alluded to this, but you see how this isn't a perfect square. And so these are actually all no data values right here in my result. Okay? But in your result, they might not be no data values. So in order to solve that problem, anybody think of a way to solve that problem? These are all no data values. So I want to keep them as no data values. So you're going to have an empty .where statement somewhere. Basically, you're going to have to do it. You could do it as a con statement, and once you turned it back into a raster. But you have to have a conditional that says if it is no data in the original raster, it has to be no data in the final raster. See. But those are minor things. Remember, you're going to miss at most 5 points for either of those two things I just talked about. So don't like let it pull your hair out. Just try to find ways to solve those problems. But if you wouldn't even notice it really unless you zoomed way in. So like if you bring them both up in ArcMap, and my result and your result are like right next to each other, but one starts here and one starts here. And you can't figure out why. It's the snap raster, but if you can't figure out how to implement it, that's only going to be 1 or 2 points. And then if all these show up as zeros or not no datas, as zeros or negative 73, like some weird number. It's because you need to put a where statement in like we did last week and pull those values out and make them zeros now. There's a few different ways to do it, but I think the easiest way is to say if there were no data originally, they should be no data in the output. All right. Any other? I don't think there's too many other issues. All right, so the written portion of the exam will be given next week along with a video for y'all to watch. Okay. Please feel free to email me. I'll be accessible by email. I'm actually not going to Hawaii anymore. It's the Dominican Republic now, but we're still testing the same thing, same system, and we're actually combining it with another project. Eventually, we'll go to Hawaii because we do have the money to go there. But anyway, I'll be in the Dominican Republic. I have email every evening, so I'll be able to answer questions. And please feel free to ask questions that have to do with the logic. So, I'll even direct you to, if you understand the logic, I'll even direct you to the help on something that will help you. Okay, but I'm not going to like type out the code like I have sometimes for other examples. I'll be here tomorrow. Yep, I'll be here tomorrow, and I will be here. It's after the due date, but it's not after the late due date. So I'll be back on the 6th. So I'll be here for that last week for help on either this or the final project. 9 o'clock. Yeah. Well, I'm usually here a little bit before 9, but that's the time it's. Yeah. Drop my daughter off for school. Yes? Sorry. I'm done.
Mark, I sent you an email this morning with a question. Did you take a look at that?
Yes. Yep. Yeah, Mark, I saw that. Yeah, I will. I'm in classes all day today, so that's why I haven't responded yet. But normally, when I'm not in class, I'll respond more quickly than that.
Which I think the question that I asked, it looked like when we were doing that in the lab, the code wasn't working up there for you unless you put it in the shell. And then it was confusing as to whether or not we solved it.
Oh yeah, I did read over your question. So I had a couple of people up here that had the same issue, and the way we solved it up here, I'm not saying it's that way for yours. But the way we solved it up here was that we put it in the shell and we put individual I tried adding 2 at a time and then 3 at a time and 4 at a time, and finally we found out that one of the data sets had become corrupted. And so we had to re-download the data set, and then it worked. So I was gonna look at yours and give you an answer, but make sure that in our catalog you can see all of those data sets, and then none of them say this data set can't be displayed. But anyway, that's one thing it could be.